The presentation now is about usage billing with Beam. My name is Narayanan Venkateshwaran. I am an engineering manager at LinkedIn. I manage a team which does the monetization platform. And with me, we have Jingjing, who is the billing lead within LinkedIn. Today's presentation will go over this concept of usage billing and how we use Beam framework to re-architect our current system. So the agenda for today would be pretty small. I think we'll start out with what usage billing is. I don't know if many of you are familiar with usage billing, so we'll go over the concept of usage billing and we will talk about some of the challenges we faced with our current system or sort of the legacy system, and then we will talk about how we re-architected the system with the new Beam pipeline, along with some of the points on how and why did we choose Beam and what benefits we found. So usage billing, I presume many of you have encountered in your day-to-day life. It's like when you buy something and you're charged based on consumption. The most common use case is your electricity bill. So you are being charged based on consumption. So that's sort of a usage billing, but that has been more mainstream nowadays with all your infrastructure as a service like AWS, Google Cloud, who charge based on the consumption like storage or any throughput. So similar to that, we have usage billing going into subscriptions as well as some of the software we try to sell to our customers. Usage billing has two components. One of them is usage, which is like a consumptions which comes in, and you how do you kind of rate them and bill them. So within rating on billing, there are a couple of concepts I want to talk about. First is threshold. So when you are getting a usages, right, you need to figure out when to charge the customer. Generally, with the electricity bill, it's at the month end or some anniversary you have. But sometimes, which in our use case, we'll talk about we want to charge a customer when you reach a certain amount or a certain action which a customer takes, we want to charge them. Usage billing has some advantages from a monetary and revenue perspective that you can be more, how would I say, charged based on certain consumption you want to do. For example, you are having a cloud usage, you're using it too much, you can tone it down, you can optimize it further. So this, even though it's variable cost, it allows you to forecast things much better. And usage billing is very useful for customers because now they can see what they are paying for rather than an upfront fee. There's one concept I haven't gone through in this. It's called metering. Metering is sort of like how much you rate a usage. In our examples, we are not going over metering because that's not something we have built, but that's very common use case again in cloud pricing where you want to charge, let's say for 1000 gigabyte, you want to charge $2 or something. That's called metering, which we are not going to talk about. So usage billing in LinkedIn is predominantly two big use cases. One of them is jobs and another is ads. Jobs is when you post a job, you kind of get clicks, you get impressions, you get applications, and you want to basically make sure you charge the company which is posting a job based on this impressions. And it's sort of a streaming list of usages which we get. Similarly, we do it for ads, which although it's more auction based, we kind of the price is predetermined based on the some of the factor and criteria you select. But eventually, you do get a streaming list of prices to us on the usage billing platform, and you charge them based on certain thresholds, which I talked about earlier. Again, these two are heavily monetary systems because you want to make sure that you're charging customers accurately for the usages they consume. Some facts about the usage billing at LinkedIn. Right now, we get around 9,000 job applications per minute. Some of them are free, some of them are paid. For the paid ones, that's where this usage billing comes into picture. We support 30 plus currencies in LinkedIn, so since we are global. And we are also supporting something called invoicing and credit card billing. What these two things means, credit card bill is you put your credit card, you get charged when you meet a threshold. Invoicing us for big, massive customers or whales who basically wants to like accumulate a lot of usages, but generate an invoice which they can pay through checks or any other bank transfer because these are big amounts. And usage billing is such sits in the middle to collect these usages and charge them according to that. This is our current pipeline, which we have for usage billing. It has been serving us well for quite some years, but it has start showing some scaling challenges. So all it starts out from the, if you read from the left side, you have ads and jobs, our services which are sending us usages. And these usages are sort of two big APIs they call. One of them is batch create, where they send these usages in a RESTly way. And they also tell us when to trigger the charge, because that kind of gives them the control. But that's, I'll go in the next slide where that is creating problems for us. It's these usages, once we capture it, we store it in our database. We call it auto database. And then we have, well, this is where it gets interesting. There are some storage procedures which we have in Oracle, which allows us to basically run some event queue, which basically stores these events. And we use something called Oracle AQ. It's a middleware hosted by Oracle. Again, it's not within an application control, it's within the database control. And it kind of treats these usages and makes sure this charges them based on the rules we have set up in the code. As you can see, it's pretty much an architecture which served us for the past few years. It's a bit of a legacy, starting to show challenges. Some of the big challenges we have faced recently is, again, this was built in a batched way, as in we get these usages a couple of times a day in a batch way, and we run these processes, and these processes are triggered by our LOBs, in this case is ads and jobs. Over a period of time, challenges come in terms of these batch sizes are increasing, which means our threshold billing detection logic is taking long time to process and finish, which means it can stretch into multiple execution windows, which means customers may not receive their bills on time. Also, the stack is pretty legacy. I mean, stored procedure and Oracle AQ. I mean, come on, who uses it nowadays? So it's something we want to move away from. Code was also written in the sense that we wanted to support these growth businesses, ads and jobs. It was not built in a platform friendly way. What I mean by platform friendly is there could be many use cases we want to support, either in ads or jobs, or a new type of billing we want to do for different products we want to sell. So that won't scale because these code are pretty much hard coded based on consumers. This also had scaling problems. As I mentioned in the previous slide, yeah, some of these workloads take long time to finish, and we want to scale our system as our growth needs increase. There is sort of a fault tolerance missing too in these systems, because usage billing cannot be treated as something you send it and you forget about it. There is situations where customer may complain that, hey, I don't like these usages, there's something is wrong, or there's some system issue which doesn't allow us to process these usages correctly, so we need to send them rectification events. These kind of things are hard to do in this architecture, and sometimes these batches fail. And when these fail due to either encoding issues, bad data, you have to restart the batch for figure out the time. There's a lot of toil being involved in these systems. And that's why we as a company and team chose to revisit this architecture and build a new usage pipeline. There are some other things too, which I don't want to go in detail, the things around revenue recognition, where you want to make sure whatever customers you are getting charged, it goes into the ledger of our LinkedIn system to say that we have paid. These integrations were also starting to creak with this current architecture. And that's why we thought of revisiting this whole architecture and rebuilding it. So I'll go to the next slide and hand it off to Chengjing, the tech lead on the billing side. She can go over the new architecture and also go through some of the advantages of using Beam.
Thanks, V. Now, let's quick walk through our new usage billing system, highlighting in the Beam pipeline component. Our process started with ads and job generating usage events, which is sent as a usage event through Kafka. The pink dashed line over here represents our new Beam pipeline. The pipeline begins with the usage ingestion standalone Samsung application. It consumes the Kafka event from the Kafka topic and then interacts with the usage processor service to persist and store our usage into the usage billing database. A key feature is the change data capture events from the database fed into the Brooklyn pipeline. Those events are then repartitioned by a new key. The repartitioned data goes back to the Kafka and is consumed by the usage post-processing pipeline. This is where we perform threshold detection and triggering billing when necessary. If billing is required, then the usage processor service will communicate with the downstream billing service to generate invoice and calculate the tax. Now let's go to the next slide, where we focus on our main three Samsung pipelines. First, we have the usage ingestion pipeline. So this is our data entry point. The pipeline reads the message from Kafka and unpacks individual usages. It also applies various filters and perform idempotency check to prevent duplicate data processing. A key feature is its ability to dedupe and aggregate intraday usage, streaming our data flow. It also manages a data ladder queue, allowing us to handle and investigate any problematic usage. Next is our usage broken repartition pipeline. This plays an important role in optimizing our downstream data processing. It reads the usages from a Kafka topic and repartitioned based on a specific criteria to processing, which is essential for improving the efficiency of the subsequent processing steps. The pipeline also applies various filters and transformations to the data that will ensure only valid and the necessary usage will continue to be processed. This pipeline also applies various filters and transformations to the data, which is essential for improving the efficiency of subsequent processing steps. The pipeline also outputs the processed data back to the Kafka for further processing. Lastly, we have our usage post-processing pipeline. This is where the core of our logic resides. It processes the usages with specific states, such as created, holds, and delivers, allowing us to track the life cycle of each individual usage event. This pipeline performs critical data validation to maintain the data integrity. Importantly, it also leverages the Bing for state management and the timer functionality, which will be discussed in more detail in the next slide. Like other pipelines discussed above, it also includes a data ladder queue to help us to manage any problematic usages. All right, now let's take a look at the threshold detection task, which is within our post-processing pipeline. So some context. In our system, I think we also mentioned about a threshold represents either specific limit or trigger event for a usage that prompts billing action. It can be a dollar threshold or timer threshold. Our threshold detection task is really important for usage-based billing. It tracks customer usage. It detects when thresholds are met, as well as triggering the billing actions. This process needs to be reliable and scalable and able to handle both real-time processing and the time-based checks. Bing provides two key features that make this possible: stateful processing and the timers. Stateful processing allows us to maintain and update aggregated usage data on a customer basis. For new usage comes into our system, we updated the aggregated usage state, which being managed and persist for us. This ensures we always have up-to-date view of each customer usage, even in a distributed environment. Timers, on the other hand, enables us to schedule future actions. We have two types of timers. One is based on the billing cycle duration, and another one is for a specific calendar dates. This timers ensures we check threshold regularly, even without the new usage coming in. Now let's walk through this process at a high level. We first receive usage events and update the aggregated usage state. Then we set or update our timer. We check if the threshold is reached. If yes, then we initiate billing and clear state. If not, then we will wait for the next event. It includes a new usage coming in or a timer firing. When the timer fires, we perform another check. All right, as discussed above, and Bing brings several key advantages to our usage billing system. It supports both batching and streaming processing. It also supports multiple processing tiers, including Sensor and Flink, which allow us to pick up the most effective execution environment. It also supports sophisticated window options, including time-based window, amount-based window, and action-based window. Lastly, it also guarantees the exact one processing, which is really important for our monitoring system, like our system. All right, now let's take a look at like a code example. So this code snippet shows how we have structured our Bing pipeline for the usage processing. We begin with reading the messages from Kafka topic and then perform a couple of transformations, including transfer the Avro record, filtering out all the events that are ineligible for billing, as well as filtering out all the events that are ineligible for detection. Each step, we use the Pardue for the parallel processing. All right, so lastly, let's turn our attention to how we actually monitor our Bing pipelines. Effective monitoring is really important to ensure the reliability and performance of our system. So we have implemented a comprehensive monitoring approach that covers 3 key areas: Bing-specific counters, JVM metrics, and the Kafka metrics. So first, let's take a look at the counters. So this our customized metrics we have implemented within the pipeline. This will help to check specific events and outcomes. And the next is JVM metrics. And we pay close to the JVM metrics because we're using the Samsung standalone for the SOX compliance purpose. So we have like 3 key indicators: RSS memory to help us indicate like the overall memory usage. JC scores give us insights to the garbage collection utilization, as well as the CPU usage percentage. The last one is the Kafka metrics. So we monitor Kafka because Kafka is a really important component to our system. We focus on metrics such as the partition stopped, total lag, as well as the partition lag. So those graphs actually shows a visual representation of those metrics over time. And we also set up alerts for each metrics. As you see, based on those alerts, we can quickly identify any like anomalies. Okay, I think that's it for today's presentation.